ENCLAPSലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hi, we've already learned about the law of conservation of energy, potential difference and Joule's law. Let's go into some details. In Joule's law, resistance is a major factor influencing heat. A resistor is a device used to provide resistance in a circuit. Let us now see two different arrangements of resistors in a circuit. The first one is a series connection. Just like a human chain, the circuit is completed in a single path by continuously arranging the resistors. This is called a series connection. Let us see a video.
Resistance in series. When the circuit is completed, current flows and the bulb glows. When the number of cells are increased, the voltage and current increases. Because of that, the bulb glows much brighter. When the number of cells are decreased, voltage and current decreases. The intensity of light from the bulb also decreases. When a 5 ohm resistor was included in the circuit, the current decreases. Now the ammeter reading is 1.8 ampere. That is, the current in the circuit is 1.8 ampere. When a 10 ohm resistor is connected in series, the ammeter reading is 0.6 ampere. That is, the current in the circuit is 0.6 ampere. The current in the circuit decreases. That is, when resistors are connected in series, the resistance increases. Both the ammeters are having same reading. That is, in all the resistors, same current flows. Now, when a 30 ohm resistor was connected in series in this circuit, then the ammeter reading is 0.2 ampere. That is, the current in the circuit is 0.2 ampere. The current decreases. When the resistors are connected in series, then the total or effective resistance increases. All the three ammeters are having same reading. That is, same current flows. But look at the voltmeter reading. They are different. That is, when the resistors are connected in series, then different resistors will have different potential difference. From the voltmeter, it's clear that for higher resistance, there will be a higher potential difference. And for the lower resistance, the potential difference would be lower. If the total resistance is R and current is I, the potential difference at R1 is V1 is equal to IR1 and the potential difference at R2 is V2 is equal to IR2 and the potential difference at R3 is V3 is equal to IR3. Total voltage V is equal to IR. V is equal to V1 plus V2 plus V3. IR is equal to IR1 plus IR2 plus IR3. IR is equal to I into R1 plus R2 plus R3. Therefore, the total resistance R is equal to R1 plus R2 plus R3.
The series effective resistance or the total resistance is a sum of resistors, that is R1, R2 and R3. Therefore, the effective resistance is R is equal to R1 plus R2 plus R3. What are the characteristics of a series connection? The effective resistance is increased. Same current flows through all the resistors. The potential difference for each resistor is different. and only a single switch is needed in order to control all the resistors. So here we are clear with the series connection. The next one is a parallel connection.
Resistance in parallel. When the circuit is completed, current flows through the circuit and the bulb glows. When number of cells are increased, the voltage and current increases and bulb glows brightly. When the number of cells decreases, voltage and current decreases and the intensity of light of bulb also decreases. When a 5 ohm resistor is connected, the current in the circuit decreases. The ammeter reading is 1.8 ampere. That is, the current in the main circuit is 1.8 ampere. When a 10 ohm resistor is connected in parallel, the ammeter reading of the main circuit is 2.7 ampere. That is, the current in the circuit is 2.7 ampere. When one more resistor was connected in parallel to the first resistor, then the effective resistance decreased. That is why the current increased. Look at each of the ammeter connected to each resistors. All the readings are different. 1.8 ampere current flows through the lower resistor 5 ohm and 0.9 ampere current flows through the higher resistor 10 ohm. That is, the main current gets divided into two paths. More current flows through the lower resistor and less current flows through the higher resistor. Now, when a 30 ohm resistor is connected in parallel, the ammeter reading of the main circuit is 3 ampere. That is, the circuit current is 3 ampere. So, when the number of resistors connected in parallel increases, the effective resistance decreases and the current increases. That is why the current in the circuit increased again. The current in the main path gets split up into 3 paths. In all the resistors, they have the same potential difference. In a parallel connection, if the total resistance is R, then the current through the resistor R1 is I1, through the resistor R2 is I2, and the resistor R3 is I3. Total current I is equal to I1 plus I2 plus I3. V by R is equal to V by R1 plus V by R2 plus V by R3. V into 1 by R is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. The total resistance or the effective resistance 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3.
What would be the effective resistance if 3 resistors are connected in parallel? In a parallel connection, we take the reciprocal values of the resistance, that is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So, if 2 resistors are connected in parallel, what would be the resistance? It would be 1 by R is equal to 1 by R1 plus 1 by R2. Either you cross multiply the right hand side or take the LCM, we get 1 by R is equal to R2 plus R1 divided by R1 R2. That is, we need the resistance, isn't it? So, we will take the reciprocal value again. The effective resistance R is equal to R1 R2 divided by R1 plus R2. Remember, this equation is only applicable if we have 2 resistors connected in parallel. What are the main characteristics of a parallel connection? The effective resistance is decreased. The current through each resistor is different. The potential difference of each resistor is same and each resistor can be controlled by a separate switch. So I hope you're clear with the peculiarities of the series and parallel connection. Now let us move on to some questions related to this topic. 5 resistors of 3 ohm are connected in series. Find the effective resistance. Here, 5 resistors of 3 ohms are connected in series. So what we have to do? We have to take the sum of all the resistors. That is, R is equal to R1 plus R2 plus R3 plus R4 plus R5 is equal to 3 plus 3 plus 3 plus 3 plus 3 equal to 15 ohm. If same resistors are connected in series, in order to calculate the effective resistance, it is sufficient to multiply the value of resistor by the number of resistors. That is, effective resistance here can be calculated by using an equation R is equal to NR. Here, capital R indicates the effective resistance, the lowercase n indicates the number of resistors, and R is a value of resistance. It's so simple, isn't it? Now, let's solve this problem using this formula and substitute the values. R is equal to NR. Here, small letter n is equal to 5 and R is equal to 3 ohm. Therefore, effective resistance R is equal to 5 into 3, which is equal to 15 ohm. From the same question above, what would be the effective resistance if the same resistors are connected in parallel? R is equal to R divided by N. The effective resistance is R is equal to 3 by 5 equals 0.6 ohm. Next question. What will be the current if 4 ohm and 2 ohm resistors are connected in series and potential difference of 6 volt is applied between the terminals? Given that the potential difference V is equal to 6 volt, resistance R1 is equal to 4 ohm, resistance R2 is equal to 2 ohm. Here it is a series connection. So R is equal to R1 plus R2 equals 4 plus 2 equal to 6 ohm. What we need here is to find out the value of current. According to Ohm's law, I is equal to V by R. Therefore, the current I is equal to 6 by 6, it is equal to 1 ampere. Let us now move on to the next question. What will be the value of current if 12 ohm and 4 ohm resistors are connected in parallel and a potential difference of 12 volt is applied between the terminals? Given data are the resistance R1 is equal to 12 ohm, resistance R2 is equal to 4 ohm and the potential difference V is equal to 12 volt. Here the connection is parallel. So the effective resistance will be R is equal to R1 into R2 whole divided by R1 plus R2. That is, R is equal to 12 into 4 divided by 12 plus 4. The effective resistance R is equal to 48 divided by 16 equals 3 ohm. In order to find the value of current, we apply Ohm's law. I is equal to V by R. I is equal to 12 divided by 3 equals 4 ampere. Therefore, in order to find the current passing through a series of parallel resistance, it is sufficient to divide the potential difference by the effective resistance. I hope the series and parallel connection are understood. See you with a new topic.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ Enclaps, the learning app.